kinds of issues. All right, so it's not going to let me do that. All right, so you start with the ordered pairs here. So this is a 2, -2. And then B is, I know this is all sort of straightforward. I'm going to make some comments there that I think will be helpful. 5, 3. And then D is 4.
3, right? I think
3, yeah. Now, one of the really important things to do, this applies more to rotations, is generally you only do them like one at a time, meaning that like manipulate all the X values. So in this case, 4 left means you're going to subtract 4 from every single X value, every single X value. Okay.
So then
so that means like
-2, 1, 1,
and 0.
0.
And so the way our
That's
brains
just a
work,
faster way to do it.
yeah, the way our brains work is we can do that better than we can do 2 rules at a time. So now look, you're going to go 2 down. That means you're subtracting 2 from each of these.
Yeah, so then that would be 0, -2,
So
1, and 1.
you're subtracting 2, -2 minus 2, you're going left to -4.
Right.
And then 1, and then 1. So sometimes it's good to even write what that means. It means X goes to X -2, -4. Y goes to Y -2. That's also perhaps even, and you kind of have that there in some of these, but you can see the table really organizes this pretty well. The next thing is that they often use this indicator, this prime, which you probably have not seen before. Prime, C prime, D prime. These are all ways to designate the new points. So -2, -4. Wait. Oh yeah, okay, that's correct. There's A prime. B is 1, -2. C prime is 1, 1, and then 0, 1 there. And so when you connect these, you should see, and you got to connect them in the same order as the original. You should see, like you said, like sort of the a video footage of okay, this shape here is moving left and then down. And the order matters. Like you have to say, okay, I'm going from the one on the right to the one on the left.
Yeah.
Okay. So I know this wasn't difficult, but the takeaway here should be, make a table, choose one to modify at a time, maybe use a different color when you're sketching it, and so on there. Any questions on that before we move on to a dilation?
Yeah, no, I don't think so. That's pretty straightforward. I like the table setup because like how I was doing it before was like I was literally counting it on that little drawing.
I see. Yeah, and that does work. You just there is more of an algorithmic way of doing it if that's important to you.
Yeah. No, I like the table. It's more like, I don't know, more proof of what you did in a sense.
It is showing your work. It really gives you a little bit of that. Okay, so let me grab, so I'm going to go out to the web here and grab something. Actually, we should do another type of transform. We should actually do, before dilation, I'm going to grab another image here. Okay. So let's say for the moment that we wanted to reflect this image over this line here, which is X equals 3. Okay. We want to reflect it over X equals 3. Is that okay for the moment?
Yeah.
So this is where you do count. This is where you like go to a point like P and you sit there and you say, okay, and let me actually line this up better with my grid so that we can count here. Let's see here. That one's kind of right there-ish. Okay, that's a little better. All right, so the P is 2 away from the 3. Do you see that?
Yes.
So this is where you count the other direction. You're like, okay, let me go 2 to the right of P. That's where P prime is. This is where it is better to count. Okay, so there's sometimes where a table makes more sense, sometimes where it doesn't, because the rule might be really complicated here. F, we look at F there and we start counting, 1, 2, 3, 4, 5, 6, 7, 7 away, 1, 2, 3, 4, 5, 6, 7 away. Okay.
Mm-hmm.
K is right on it. So sometimes it doesn't actually move. That's K prime. And then N is 1, 2, 3, 4 away from that line. So you count 1, 2, 3,
2, 3, 4.
N prime. And then it's good to do it in the order. So like we went P, F, well, we should have went P, F, N, O, but to connect them going in that direction there for that.
Uh-huh. Huh, okay. So then that was
That's over a line, over a line. Okay.
all right, so an overline. So I'm literally just
That's what,
reflecting it over and I could be looking and I'm just being like, oh, what's the opposite of this from that 3?
yes, yes. Now
Right.
it could be both horizontal or vertical. Okay. So this time let's put a line. You got to be careful here. Let's do the line like here. Okay. So you go to each of those points and you just count how many away it is from that line. Okay. So it's like
Uh-huh.
N is 2 away. So you're going to go 2 up from there. So you can see that N prime would be there. This is Y equals 1. So it actually doesn't matter where the line is. It's just how far away it's given to be.
Uh-huh.
This K down here is 1, 2, 3, 4, 5. I know you can't see me counting 1, 2, 3, 4, 5. That's K prime. Oops. All kinds of technical problems tonight. That's K prime. And then J, 1, 2, 3, 1, 2, 3, like that there.
Okay. Oh wait, so I have a question actually.
Go for it.
So there's a difference where it's like, so in this case it's y equals 1, the other one was like x equals 3. So the y is when it's going horizontally across, and then x would be for vertical. So it's like if it's y is 1, then I go like, oh, it's the like 1 up there, and then I just go
Yes.
across.
Yes.
Okay. All right. That
Now,
makes it easier as well.
yeah. So the next type of problem we're going to look at here, this is where it gets more interesting, is you can also reflect an image about a line that cuts through it.
Uh-huh.
You're like, what do you mean? Let me show you here. We're going to stick with horizontal and verticals here. So for example, here, and I'll do it in green here. I could say, do you want to go vertical or horizontal on this one?
Let's go horizontal.
Okay. So let's say I want to mirror over this line right here, reflect over this line again, Y equals 1.
Mm-hmm.
You still do the same thing. You go to every point, and we'll start with P, and you count from P how much it takes to get to the line. So it's 1, 2, 3. So you go from that line there, you go 1, 2, 3, 3 down. See how it's 3 up from
Uh-huh.
and then 3 down. K, you've got to go 1 towards it. So you go 1 away from it.
Mm-hmm. And then same for F.
Yes. And same for N. And you got to do this very slowly so that you don't somehow put it in the wrong place. You connect them, and sometimes it visually is okay. Sometimes it's too much and you're just,
Get a brain fart or
yes.
whatever.
Yeah. Yeah. Okay. So those are the nice ones. Okay. But there are 2 rules that they're not that you end up having to just memorize. Okay. So if it's not a horizontal and it's not a vertical, you have to know these 2 rules. Because these are not I don't want to say this, these are not as straightforward.
Uh-huh.
Like let's go back to the one we just did.
And sorry, you said don't follow those religiously or?
No, these are good. These are good to
Oh,
use.
okay. All right. Sorry.
These are good to use. But like what I'm showing you is the line y equals x here. The line y equals x is this line right here in red.
Mhm.
And there's not really an obvious, like you can't just sit there and count like, all right, P is like 2 away. Like that's not really going to happen. K is 2 away or N is 1 away. Like it kind of ends up being that way, but you got to get them perfect. And And that's why you want to use
The formula.
the formula. And so whenever you're using a formula, that's when you build the table. That's kind of the overarching thing here. So let's do this. I don't know why these don't have letters in order. F, K,
It's all
N,
good.
P. Really weird. All
Finish
right.
on the special.
This is the pre-image. So F is minus 4 comma 2.
Uh-huh.
K is 3 comma 0. And N is -1, -2. P is 1 comma 4. Okay, so we're using this top rule. Okay, and I think the rule is better sort of expressed in words here. I mean, you're going to write it down, but here's what it means. It means the y, whatever was y, you put into the x position. That's what I'm the y go, or the original, I want to say this, the original y goes into the x position. So
Uh-huh.
that means whatever our original y is, we're going to do that first. That's 2, 0, -2, 4. And again, you do these all
Yeah.
at once.
I do have a question for this.
Yep.
Um, so why is like how do we know the line is going like that, kind of
This line,
covering both x and y in a sense?
this line has a slope of 1 and a b value of 0. So it starts at the origin, rise over run, rise over run.
Uh-huh.
That's how you know.
So then okay, so then is that the only way that can be shown, or can it be like also like x equals y?
Mm,
Like is this kind of like a rarer kind of
I think
formula for using?
maybe you're overthinking it. I mean, y equals x is a standard way of describing this 45-degree line.
Uh-huh.
And so to answer your question, like, yes, you can write it as x equals y, but that's kind of like saying 3 less than x. You really want to say x greater than 3. You could say x equals y, but really it's y equals x.
Okay. All right.
All right.
I guess that I'll just keep seeing how it goes and then I'll see that.
All right. So now the last transformation here is that x value, whatever the x value is, it goes into the y position. So you take each of the x values and again, you label that there. Again, sometimes these don't actually make any sense when you're like writing the formulas. You just do it and then hopefully it works out. So 2, -4 ends up being down here. That's P. I'm sorry, that's F. Sorry, F. So do you kind of see that, like, if you could draw the perpendicular to the red, do you see that it's exactly the same distances away from the F is exactly the same distance from the red as F prime is from the red?
Yes, I do
Maybe.
see that.
Okay. You'll see that with the K value now. So 0, 3 is right there. Okay.
Oh,
And you can, again, if you were to just draw like this perpendicular, you would see that they're about the same.
yeah.
Okay. So we got to be careful not to have too many lines in this. Let me get rid of those, and then
Yeah.
we'll label the next two: -2, -1, 4, 1. And why does that not look right?
Um, no, I think it looks good. Wait, no.
Yeah.
I think your the N might be one spot too high horizontally, maybe.
Oh, it's in the wrong spot altogether. Should be further down. Good catch on that.
Oh, good. I wasn't looking at any of the math for it, by the way. I was just looking
There,
at the
there
picture.
it
So
is. Yeah,
I
no,
don't deserve too much credit for it, but
well, you did see it. You did see it. This is more of a, this is not really math. This is more about pattern recognition,
yeah.
visualization. Like what makes a good what makes a good picture, what makes a good drone video. I don't
Uh,
know. There's something that captures the eye. So
yeah. I actually have a question with the next or the through the origin coordinate plane
yeah,
rule.
yeah,
So what it
whatever.
says x y minus x minus y. Um, what happens if one of the numbers is already a negative? Does it become a positive? Like let's say
Yes,
x is -3, then would it just be converted to +3?
yes. It means change. This really means to change the sign.
To change the sign.
Because that I think more literally more in our English language means if it's positive, it becomes negative. If it's negative, it becomes positive because we only have two signs. It's like when you go to a light switch and you turn it, you already know the other outcome. If the lights are on and you flip the switch, it turns off. If it's off and you flip the switch, it turns on. Like there's only two possibilities. So when you change the sign, you know that if it's positive, it goes negative, negative goes to positive. That's what this rule is saying. It's not saying it always becomes negative. It's saying that whatever its sign was, you're changing it.
Okay. All right. Change the sign. Okay, so yeah, okay, I guess that makes sense. Just it's always going to be changing whenever it's through the origin. Like it'll never just stay the same
Yes.
unless it's 0.
Right. 0 was neither positive nor negative, so it does not change. Okay. So ready to do some dilations?
Yeah. Let's see it.
All
Yeah, I
right.
kind of like that this stuff isn't too tricky.
It is not. It really does come down though to knowing these formulas. All right. So a dilation, in short, is either larger or smaller. And it depends on what's called a scale factor.
Oh,
Okay. Like now sometimes like if you're taking a picture or photograph or something, I think, and you see this sometimes on social media, it's always good to put a reference in, like a quarter if it's not too big,
yeah,
a literal quarter, or you know, I don't know, something that's got some size that we all, like a basketball. If you need height, a basketball hoop's 10
yeah.
feet.
Like if you
I mean,
take a picture of like a building, there's like a trash can outside of it or something.
yes, yes, you get some semblance of that here. Um, so here's the short of it is if k is greater than 1, it gets larger. If k is between 0 and 1, it gets smaller. One of the most important things here to do, though, to recognize is because sometimes they will give you they'll give you the pre and the post image, and you have to know whether you're getting larger or smaller because your scale factor will depend on that. Like if you're going from the MNOP to the larger one, your scale factor is getting larger. But if your original one is this bigger one and you're going to the smaller one, your scale factor is gonna reduce it.
Hmm.
Okay, so just like in the previous problems, though, we're going to make a table here. Let's assume we've got a k value of 2 in this problem, and I'll show you what to do next year. So let me grab this image, and we're going to label the points M. So put that M N O P. Go ahead and give me those ordered pairs if you can. Well, actually, you've got them on that piece of paper. Never mind. I'll just write them
Your
down. All right, 1,
cheat
3.
sheet.
Yeah.
I mean, your cheat sheet, of course. Like,
Yes.
it's, yeah.
All right, so now the k factor of 2 means to multiply both x and y by 2. You literally multiply both the x and the y values by 2. I still recommend doing it one at a time. 2, 6, 4, and -2. And then multiply the y values 6, 4, -4, and 0.
So we know with this size one that we're just multiplying all this by 2.
The
And because
dilation, whatever the dilation is, you multiply both x and y by that number.
and that's because it's growing.
In this case, it's getting larger, yes.
All right, yeah, then 2, 6, 4, -2, 6, 4, -4, 0.
Yes. So we're going to plot these on the graph now. 2, 6, 1, 2, 3, 4, 5, 6, 6, 4, and 4, -4. Wow, I'm really forgetting parentheses all over the place. 4, -4. There's that one, and then -2, 0. Something like that.
All right. Yeah. Um.
So let me find a better problem than this, which is what I was trying to
So I'm assuming for shrinking it, it would be dividing by 2, of course.
or dividing by 3 or dividing by 4
Oh,
or so on.
correct. Yeah. Whatever the number is.
All right, so here's a problem here. Let me snip this in. Okay, so this is a problem. It says describe the dilation of quadrilateral MNOP. Don't worry about using the origin as a center. You're always using the origin as a center for now. This is always true. Okay, so here's why I brought up this question is you want to recognize what you're starting with. They're telling you you're starting with MNOP. The new image is the prime. So that's an important thing to write down or take note of. Is the new image, or the post image, is always the prime.
Oh.
So if they don't tell you, you can just use that as a guide. If it's prime, that's the new image.
So so for the origin as the center, so
That's always true. That's just, I don't know if you remember in chemistry, they would say things like, assume that you have enough of the reactant, the other reactant, to do this. Like this is always true. Like it's not needed. You don't even need to say that. That's always true for your problems.
so we'd in this scenario have so is the origin, it's not 0, 0, correct?
Yes, the origin is 0, 0.
Oh, okay. So just use, okay, my bad. All right.
But you
I was
don't do
just
that.
thinking because that one thing wasn't perfectly centered with 0 in the middle. I was like,
So here's how you do this. You take a point like M and you write the coordinates of M. M is 3, 3, and M prime is 1, 1. And you answer the question, how do you go from 3 to 1?
you have to subtract by 2.
So your answers are multiplication or division.
Oh, sorry. Yeah.
Good try.
I was close. I was close. You'd have to divide by 3.
You divide by 3, or you can think of that as multiplying by 1/3. So they always want you to use multiplication in these problems.
Oh, okay.
Okay, now here's, I should have labeled at least one more point. Let's say we wanted to go from n, which is 9, -3, n prime is 3, -1. When you said, okay, to go from 3 to 1, you subtract 2, I should have then asked, well, does 9 go to 3 by subtracting by 2? And you would then say no. This rule has to work for everything. So is 9 divided by 3, or 9 times 1/3 equal to 3?
Yes.
Yes, it is. Okay. All right.
Oh, and then you can compare them because they're all gonna have the same.
They have to, yeah.
Yeah, or else it wouldn't work.
All right. So here's a problem that I really like that I can actually have you try. The table below shows the coordinates of triangle RST and the coordinates of R prime and triangle R prime, S prime, T prime. Basically, they're saying this is the one on the right is the new, the one on the left is the old. Okay. And they're saying that the new one is a dilation of the old. So you have to figure out the rule to go from -2, -3 to -6, -9. And then use that rule to determine the other ordered pairs.
So then,
So, but I liked first. So part A here is what is the rule? What is
it's
K?
multiplying by 3.
So K is 3. So I want you to give me the coordinates for S prime and T prime, please.
0 and 6, and 6 and -9.
Yes.
And then,
That's it. Nothing
yeah.
else on that. All right, let me see one more here or not. If not, we'll just go to sorry, it's like they're all super easy. All right, let's move on to the next one on your list here, which is we did reflections, we did translations, we did dilations. So let's go to rotations. Okay. Let me see if I've got a worksheet from another student at another school that I think was really good for this. Let me see if I can quickly find it. If not, I'll just do the ones that are there. Is this it? Nope. All right, let me find
No worries at all, by the way, for time.
rotations. Okay, so here are let's grab the rules first and then talk about some questions here. The rules, there's a couple of things here that they are not technology. Come on, my screen froze up. Okay, come on, there it is. All right, so here are the rules. You can see those. Not sure if that's sharing or not. Yes, that's sharing. Okay, so the rules here, counterclockwise and clockwise, you may be given one or the other. Like it might say counterclockwise 90 degrees, or it might be clockwise 270. Like these, the point is that these are the same rule, whether you're going counterclockwise 90 or clockwise 270. Is that clear to you? Like if you're here and you're going clockwise versus counterclockwise, you get to the same spot or not?
Yeah.
Okay, very good. So you have to learn these rules, and I don't have any recommendations for that other than to figure out what works best for you. Like there's no shortcut to learning these rules, unfortunately. But let's presume for the moment that you have them. Okay. I want you to answer this question here based on this rule. One of these three rules.
What are the coordinates of A, the image A minus 3/4 after rotation of 180? Minus 3. It would have to be 4, 3 and -4.
Okay, and how confident are you in your answer?
For 180, you said?
Yes.
Very confident.
Okay, so you take the x value and you negate it. So whatever the x is it changes sign. So that's 3. Whatever the y value is, you negate it. It is that. Now let's look at a quick sketch of where the old point is and where the new point is. Okay, so the old point is here. That's A, and then the new point is here, A prime. Now think in terms of quadrants. Do you remember that from previous class?
Very familiar name.
Quadrant 1, quadrant 2, quadrant 3, quadrant 4. What do you notice about how you go from A to A prime? Like, what are you skipping?
You're skipping, I guess, quadrant 1 and 2.
Yeah, you're like, if you visualize it as going from A down to quadrant 3 into quadrant 4, you're skipping quadrant 3. If you visualize it as going the other way from I through I down into quadrant 4, you're skipping a quadrant.
Uh,
Okay, now that'll make more sense here in a moment. Let's do another problem, referring to those formulas here. Okay, so do you have those formulas? Do you have that sheet in front of you for rotations?
I do have it in front of me.
Okay, so go ahead and let me know what the new point will be.
5, 2, clockwise 90. X, Y, Y. It would have to be 3 for -2 and 5.
Okay, so tell me the rule that you used for this.
I used the rule xy goes to -yx.
Yes, very good. Okay, so that means whatever your y value is, you change its sign and put it first. So that's why it's -2, and then your x just becomes the x. So now let's graph this. Let's do, a quick sketch of where this is. 5, 2 is there, and then -2, 5 is there. Okay, and you were in quadrant 1. We'll call that A and A prime, and then you moved to quadrant 2. Now you moved counterclockwise. Does it seem reasonable that you would move a quadrant?
Um, I guess so, since it's not.
Well, let's see if that continues here. See if that continues to work. So here's another way that it could be written. Let me snip this in. What is the image of point 8, -4 under the rotation 90 degrees about the origin? Now, does this one specify clockwise or counterclockwise?
It does not.
And you need to know that, right?
Yeah, so then I
So,
guess you'd have to.
so the standard is clockwise, CW
Oh,
for clockwise. Like if it's not given, it should be given in all your problems, but it's kind of like we know that up is north, right is positive, that kind of thing. So
oh,
consider this to be a clockwise 90-degree rotation.
okay. So then that'd be clockwise 90 degrees, so that'd be xy to y minus x. So then that would be y becomes, so it would be y first, which would then be positive, nope, -4, and x would be -8. So for -8, um, how did I mess that up?
You said all the right things, but I didn't. My
Minus
guess is,
4 -8.
so what is your final answer?
Um,
A, B.
-4 -8.
So this one?
Yeah.
Okay, so now if I just rough sketch here, 8, -4 is here. Okay, -4, -8 is here. And one of the things I think is really important to do is you draw something, in this case clockwise. So clockwise means this.
Uh-huh. Oh, so if it's in that next panel right there, it makes sense clockwise.
Do you see that it moved one quadrant again?
Yeah, I do see that now.
And that's important. They don't typically emphasize that, but it does help you when you're trying to figure out, is my answer even reasonable?
For sure, for sure.
All right, let me see if I can find another one here. All right, so here's another one. For you to try.
Counterclockwise, 90 x, y minus y, x. Two, it would be 5 and 2 and 4.
Okay, so let's confirm that graphically. Okay, so a counterclockwise rotation. So 2, -5 is here. And if I draw a counterclockwise circle like that, that means your new point should be up here somewhere.
Yeah.
And is it? Yes, it is.
All right. Not
And
not too
that
bad.
just sort of confirms what you were asking.
Yeah. Yeah, no, that's yeah, I like the how you can sort of look at it in those 4 quadrants is like more proof in a sense.
Yes. Yes, reasonableness of your answer here. Okay, so here's another one for you to look at. All right, so here's what I want. I want the coordinates of D and then the coordinates of D prime after the rotation here.
So rotation 180, so then that would be -2 and 2. -2 and 2, and then rotation 180, and it's going to be clockwise because it's not given. So then that would be x, y, minus x minus y. So then that would be 2 and -2 as my, I don't know,
Yeah,
D1,
D
D pi,
prime,
D prime.
prime. Yeah. Okay.
Yeah.
So the last type of problems that I'm going to have you look at here is to identify the transformation. And the order that you typically go in here is basically kind of what's on your worksheet or your reference sheet here. You first look for transformations, which is are you going up, down, left, right? Second thing you might look for are reflections. Okay, and that could be the x-axis, it could be the y-axis. Okay. Dilations, that's if it gets bigger or smaller. And then the last one, the hardest ones, are the rotations.
Mm-hmm.
Okay, so you kind of want to go in this order when you're looking for it. This one is a transformation. Can you tell me what the transformation is?
The transformation in that is a 180.
No, transformation means it goes up, down, left, or right.
Oh, it's going up. It's going up. Let's see. 1, 2, 3, 4. It's going up 4 and to the right. 1, 2, 3.
And why is it not going down 4, left 3? Why is that wrong?
Because I'm not gonna lie, I cannot give you the actual answer for that, but
So because it goes from J to J prime, the prime is always
oh right.
the new one.
Uh-huh. Yeah, I just did the bottom one just because it's like black's the more common color and it
Okay,
makes more sense to do like
you got
positive rather than negatives.
you got lucky on that. Okay, so again,
I'll make sure that was my learning experience for it. I'll make sure to
transformations, right? Transformations. So that's up, down, left, right. Reflections are x-axis, y-axis. Dilations, bigger, smaller. Rotations, you're either going, clockwise, counterclockwise, and so on. So look at number 3 here. Is this moving left or right? Up or down?
Well, it is moving left, and it's not moving up or down, and it's moving left by 2. No,
Nope,
it's reflecting.
that's right.
Yeah, all right, yeah, perfect reflection over um the I I guess
The
y zero
y-axis.
y axis.
So the y-axis, the x-axis. Also, uh, this is a little bit odd, but this is y equals 0, and this is x equals 0, which may not make sense, but that might be worth a note card or something.
Yeah. Sorry, could you repeat that? My computer is being a little buggy there.
Just the y-axis, the vertical one is x equals 0. The x-axis
Uh-huh.
is y equals 0. That might be good to put on a,
Little
uh,
card. All right,
yeah,
we'll do. Here, you know, let's put it on this transformations cheat sheet right now.
yeah. And just ask to have that on the test or quiz. That's always really, really helpful.
Yeah, because she's gonna have like a board with these kind of stuff on there. I'm just gonna be like, oh, this is the same thing, but just more organized. So I'll put a couple other little things on there and she won't even notice, I guess.
All
But
right.
yeah.
Well, that is going to do it for us for tonight, Zach. I'm going to go and stop recording.